Hello everyone, we are back in our pink packet and we are continuing with chapter 3, and today we're going to cover graphing. So you're going to see a lot of the same things that we've already done in our chapter 1 and chapter 2. So I am on page, let me see, 43 in your packet, and so the page numbers, if you haven't noticed, they're in the top right corner. So what we're going to talk about is how do you graph a square root and a cube root function, and then the next time we're together, so on Friday, we're going to add to that pink cheat sheet that we have with all our key points for graphing. So we're going to take a look at what are the points that we need to graph a square root and what are the points that we need for a cube root. And there are more numbers here than we are actually going to list. So what I want to talk about is, a square root function, this is our parent function, y equals the square root of x. So when we graph, we get to pick numbers for x, do the math, and get their y values, right? So what I want to do is be able to pick numbers that I can take the square root of in my head without a calculator. And again, we are going to take some of these numbers out. So for today, we're actually going to start at the bottom of the graph down here. So these numbers all have nice square roots. So that's why I've chosen 9, 4, 1, and 0. There are definitely more, like I could pick 16, but I'm picking numbers that will also just fit on our graph paper, which is usually from -10 to 10 and -10 to 10. So if I pick x to be 9, then the square root of 9 is 3. And if I pick 4, the square root of 4 is 2, and I get 1, and I get 0. So in our other chapters, we have also picked negative numbers for our x values. But what will happen is if you try to take the square root of -9, you're going to get an error message. So these actually don't even exist because you can't take the square root of -9, -4, or -1. Not yet anyway. We'll be talking about that later. So let's graph our parent function. So we're going to start with 0, 0. We got 1, 1, 4, 2, 1, 2, 3, 4, and let's see, 4, 5, 6, 7, 8, 9, and 3. And the shape just goes like this. So if you think about it, we've talked about in that first section inverse functions. And a square root function is the inverse of a squared function. So if it's an inverse, remember a squared function is a parabola. It's this U shape. And I would normally have the other half of this U. It would actually come like this. But then if I allowed this part to be there, then this would not be a function because it wouldn't pass the vertical line test. So that's why we're only going to have this part, okay? So that is our basic shape there. So it starts at 0, 0. And then if I mark this arrow, this is infinity, infinity. And we're going to want those for later. So as far as the cube root goes, we're actually going to ignore the -27 and the 27 because those are never going to fit in our graph paper. So again, when I pick numbers for x, I want to pick numbers that I can take the cube root of in my head that I don't need a calculator for. So let's start with 0, and the cube root of 0 is 0. The cube root of 1 is 1. The cube root of 8 is 2. And then I can do cube roots of negative numbers. I can't do square roots of negative numbers. That doesn't exist. But I can for negative numbers in an odd root. And the cube root of -1 is -1, and the cube root of -8 is -2. So I'm going to graph these, and this is just a dot that went through the other side. So we're going to have 0, 0. Here's -1, -1. Here's 1, 1. And then I'm going to go over to 8. So 1, 2, 3, 4, 5, 6, 7, 8, and 2. And then I'll do the same with -8 and -2. And what you should see is this looks very similar to our cube function. Our cube function was more tall, like this. So this just kind of takes it, and it looks a little more flat. Okay, so you should see some similarities between a parabola, which is the inverse of a square root function, and a cubic function, which is the inverse of a cube root function. Let's go ahead and mark our points. So this arrow means -infinity, -infinity. We got an x-intercept at 0, 0, and then this arrow is infinity, infinity. All things we did in chapter 1, we did it in chapter 2, and now it's coming back in chapter 3. So let's talk about these. Let's start with our square root function. What's our domain? So remember, domain is the x values. And so because it's a square root function, you're going to see that with our domain that we're going to have a much more limited domain because we can't take the square root of a negative number. So when I look at the parent function, the smallest x is 0, and this biggest x is infinity. And I will put a bracket around 0 and parentheses around infinity. My range, since my domain is limited, that's going to result in my range being limited as well. So remember, range is the smallest y and the biggest y. So my smallest y is 0, biggest y is infinity. It's going to look very similar, bracket, parentheses. Is this function one-to-one? Remember, one-to-one means it passes the vertical line test and the horizontal line test, and it does. We're going to say yes, it is one-to-one. All right, let's take a look at our cube root function. So in a cube root function, you can take the cube root of any number. It might not always be a nice answer, but you can always take the cube root of something. So here we won't be limited in our domain and range. Our smallest x is negative infinity, and our biggest x is infinity, and so you can write that. And again, if you don't like that, we can always switch it to all real numbers. And then the same will happen with our range, our y values. We have a smallest value of negative infinity, a biggest value of infinity, or you can write all real numbers. Is this one-to-one? Well, it passes the vertical line test, and it actually does pass the horizontal line test. This is not flat. This is slowly going up, and this side is slowly going down. So it's never flat. There's a slight angle to it. So yes, this is one-to-one. So in our shapes that we've had so far, we've only had two shapes that are not one-to-one. The absolute value shape, because this doesn't pass the horizontal line test, and our parabola, which also is not one-to-one because it doesn't pass the horizontal line test. So let's start talking about the different changes that are going to happen. So we are actually going to kind of ignore this part, and we are going to come over here, and we're just going to start graphing. So what I'm going to do is put our general formula up at the top, and we're not doing all of these. So we're just going to say y equals, and you might have that negative, you might have that a, you're going to have some type of radical. This is not just for square root, it's also for cube root. And then in our house, this time our house is a check mark. You're going to have x minus h, and outside of the house, you're going to have plus k. So you should see this thing happening over and over and over again. So remember, the negative is going to flip it. The a is going to stretch or compress it. H, remember we always do the opposite, and that's going to tell us to go left or right. And k, we're going to leave it as it is, and that's going to tell us to go up or down. So let's just take a look at a couple of these, and then we'll do some as a class. So we're going to graph each function using a geometric transformation. So let's talk about what the transformations are first. So in this one, in my house, I've got h, so this is going to go left 3, and this says it's going to go down 1. When I look at this one, this is going to be a flip. It's also going to stretch. The minus 4, because I'll take the opposite, will say to go right 4, and the 2 will say to go up 2. All right? And then just looking at some of these down here, I don't have anything in the house, so this shape will only be going down 5. And if I take a look at this one, again, I got another flip. I got another stretch. I take the opposite, so that means left 3, and then this means up 1. So just looking at a couple of them. Always think about your shape as well, because it's easy to confuse square root and cube root. So square root in our shape will be going like this. This one, because it's going to flip, will actually be like this in the end. This is a cube root, so it's going to kind of look like that. And this is a cube root that flips, so it's going to look like this. All right? So again, we're not going to do all of these. We're just going to do some of them. So the first thing I want to remember are the points that I'm using. And they're on the other side, but I'm just going to rewrite them. So for a square root, I actually only need the positive numbers of 0, 1, 4, and 9, because these are numbers I can take the square root of. And I'll get 0, 1, 2, and 3. And I don't have a stretch or compress, so I don't need to make a new y column like we've done in the past. I just need to go to 0, 0, and put my point on there, and then move it left 3, down 1. So that's all I'm going to do. Go to 0, 0, and move it left 3, and down 1. And it goes right there. And 1, 1, same thing. Left 3, down 1. And 4, 2, we'll go left 3, down 1. And our last one of 9, 3, we'll go left 3, and down 1. So it's not going to look any skinnier or wider. It's the same shape. It's just kind of in a different spot. So now when I take a look at, domain and range and stuff like this, Now instead of beginning at 0, 0, it begins at -3, -1. So think of left 3 as -3, down 1 as -1. And then my arrow, I'll still always have some type of infinity on one side of this. All right? Let's take a look at this one, a little bit more to it. So on this one, I'm going to go ahead and take my points again. So again, numbers that I can square root in my head, 0, 1, 4, and 9. Their square roots are 0, 1, 2, and 3. And now because I have a flip and a stretch, I will be taking this -2 and multiplying these y values by that -2. So 0 times anything is still 0. Here I'll get -2. Here I'll get -4. And here I'll get -6. And again, I always like to cross out those old y values so I don't get confused. So I'll go to 0, 0. And then it's going to go right 4, up 2. I'll go to 1, -2, and then move that right 4, up 2. So I'm going to do that. You can do that. So 0, 0 goes right 4, up 2. 1, -2 is also going to go right 4, up 2. 4, -4, right 4. And this 9, -6 is going to actually end up going off the graph, so I'm not going to put it on there. So it's just going to go something like this. And as far as marking my ends, let's see. I've got 4, 2. I can't quite see where it crosses the x-axis. We'll figure that out later at a different video. But this arrow is going to the right, and it's going down. So I want a negative infinity for the down part. All right, let's just try one of these cube root ones. Let's try the one that has a little bit more to it. So again, this time the cube root function, when I make my table, I do want to remember to use the cube root x values. And then when I take their cube roots, I'll get -2, -1, 0, 1, and 2. And just a reminder, if you don't know where the cube root button is on your calculator, you can just press the math button over on the left. And I know it's a little hard to see with the light from my window. It's actually the 4th option down at the bottom. All right? Okay, so I do have a flip and a stretch, so I'll be taking all of these y values and again multiplying them by -2. So -2 becomes 4, this becomes 2, 0 is still 0, this becomes -2 and -4, and I don't need those y values anymore. So I'll go to these points, move them left 3, up 1, and then the video, I believe, is going to be done for today. So let's go, let's see. Let's just start with -8, -4. So left 3, up 1, that goes off the graph, so I really won't worry about that one. -1, 2. So left 3. 0, 0, go left 3, up 1. 1, -2, left 3. Let's see, 1, 2, 3, up 1. And my last point, 8, -4, 2, 3, and up 1. So, if you kind of want to estimate where you think this point is going to go for help of graphing, -8, 4, and it'll go left 3, up 1, it might be somewhere like here. So you could probably get a guess of it. All right, so again, as far as marking my ends, this is going left, and it's going up. I can't quite see exactly where it's crossing the x-axis. Again, there is a way to figure it out, but we're not going to worry about it today. And this arrow is going right, and it's going down. And that's it. That is our video for today. We're going to come back together as a class. We'll probably do one more graphing, and then we're going to do this problem at the bottom.